All right. Where we go? Here we go. All right. So, we gotta do a few housekeeping things. Going live. Okay. What are we doing? Okay, what are we doing? How are we gonna do it? There we go. Okay. So if you look, here is my abacus and my abacus and what we're going to do, we're going to look at the abacus. When we look at the abacus, we're reading how to read the abacus. When we read the abacus, we're looking at the 1. So if you notice, this is 1, and then I should find a way to do this fun. And then this is 2, this is 2, and then this is 3, this is 3. If you look, this is how we read the abacus. When we read the abacus, we want to be able to see what the beads look like on the abacus. I don't see anybody here. What's going on? So what's going to happen is we're going to read the abacus. So this is 3, and then now we have 4. Welcome everybody. I was a little lonely. This is 4. On the abacus, this is 4. So what we do is we have 4. All the beads touching the horizontal bar is considered counted. Because it's counted, this is 4. 1, 2, 3, 4. All the lower beads has a value of 1. Let me know if you have any questions. Hello Ethan. Hello Ethan. Welcome back. Welcome JB. Thank you so much for the hearts. Okay, so what we're doing is we're reading the abacus. When we read the abacus, and if you're looking for this worksheet, it's in my bio if you want to look in it. Okay, if you want this, it's in my bio. But I do have this available if you want to follow along. If you want to follow along. Thank you. Thank you. It's kind of early right now. Hey, balls. Yeah, welcome. Did you have a good night? It was a really late night yesterday. I feel like one of those. Yeah. Welcome. Okay, so what we're going to do is if anybody wants this worksheet, it's available in my link in my bio. Thank you, Ethan, for the compliment. So what we're going to do is we're going to read 0. This is 0. This is 1. When we do that, this is 1. This is 2. And this is 3. And then this is 4. It's funny because I call this the big brain notes. So what we're doing is we're understanding how to read the abacus. When we understand how to read the abacus, yeah, it was a really late night. Yeah. Yeah, I'm feeling it. My eyes are a little bit shot right now, bloodshot. Okay. I feel like I went to a party and I drank a lot, but I didn't. Okay, so what we're going to do is we're going to read the abacus again. When we look at it, we want to do 0. So this is 0, this is 1, this is 2. When we have 2, this is 2 beads. After 2, this is 3. After 3, this is 4. 3, this is 4. So if you look, we have 4 beads that's touching the horizontal line. Hey, Kate, welcome back. Yes, excuse me, we are back. Thank you so much for the likes. So we have 5, and let's see how far we can get to this time before my class starts. Because I have a class. I have to leave in about a half an hour and a half. So, because I have to drive to my class. So let's see how far we can get. So this is 5. If everybody's understanding, we're doing 5. So this is 5. All the top beat has a value of 5. All the top beat has a value of 5, and then what will happen is we have 6. Notice we have 6, and then we have 7, 7. We have 7, 5, 6, 7. What grade do I teach? I don't teach a specific grade because Abacus doesn't have a specific grade, but I am planning to make grade specific Abacus worksheets, if that makes sense. Usually people who take Abacus usually takes it like an enrichment program. So I have an enrichment program. The kids that come around are I teach as young as 3 years old, and right now the oldest student that I have is about 7 or 8. Like we can go older. We can go older for if they're open to learning new things, right? So if they're open to learning new things, then I can teach older. I am planning to create more worksheets that are more age and grade specific, if that makes sense. But yeah, Abacus doesn't actually have a specific grade. It's more like an enrichment. But I think I'm gonna change that. I'm gonna have a preschool Abacus information. I'm gonna make it into a kindergarten, first grade, second grade, third grade, fourth grade, and fifth grade But after fifth grade, it doesn't make sense because I think sixth grade is when they start doing geometry and trigonometry or whatever, pre-calculus or what have you. Because I think after fifth grade, they do division with decimals. I guess you could do grade six with decimals as well. So it'd be division and multiplication with decimals, if that makes sense. But yes, so that's what my plan is. So we're going to come back to here. We have 5. This is 5. This is a value of 5. The top bead always has a value of 5. And this is 6. After 6, we have 7. 1, 2, I'm sorry, 5, 6, 7. And then this is 8. 5, 6, 7, 8. So when we look, 8 looks like this. 8 has 1 bead on top and then 3 beads on the bottom. 1 bead on top and 3 beads on the bottom. And then we have 4. No, not 4. 9. We have 9. This is 9. So what you might be wondering, well, what happens after 9? Well, what happens after 9 is 10. If you notice, 10 looks like that, but that looks very familiar with this, right? The only difference is the only difference is the place value. So if we look, this is 1 and then this is 1, but it's not 1, it's 10. How do I know? Well, if we look at the place value, we have our place value, we have our ones, our tens, our hundreds, our thousands, and our 10,000. When we look at it, every column is a place value. Each place value, right, always goes to 9. So if you notice, this is 9, this is 9, that's 9, this is 9, this is 9. They're all holding hands. When they're all holding hands, and that means they're all being counted. I bought an abacus. Whoa! And the coloring books, really? Hey, that's fantastic. The coloring book? That's funny. That's funny. Just so you know, the coloring book. Oh, that's funny. You know what? Let me know what you do with your coloring book because I would like to see the designs you have. So this is the coloring book that girl was talking about, and just so you know, just to see. I mean, I got really bored. Not bored, but I was like, this is kind of interesting, and so this is my coloring book. And if you look, I have it where it goes to 1, and then I go all the way to like the individuals. But I would love to see what you do with the coloring book. If you can like take a picture of it, would be good. TikTok University at work. Miss Lab. Yes. How do people do this mentally? Before I continue. So this is just the designs that I came up with. But hopefully I hope you will. I'm sure. Oh, that'd be awesome. Yeah. There's not too. I was like, I want to know what other people do. So then after that, you go to the teens, right? And then after, I think 30. So you go every other number, just so you know. I don't know if you know, but I'm going to tell you. So just so you know, I'm actually quite excited with this. And after 29, after 30, then it goes by tens because I didn't want it to be too big, right? So it goes to by tens, and then the final one is 100. But yeah, it would be great. That's awesome. That girl. Okay. That's new? No, it's not new. That was one of the that coloring book has been around for a little bit. Yeah, Ethan. Okay. So we did that. We did that. Any tips on getting the bead faster at beads? Yeah, practice, Ethan. It's a lot about practice. Really, it's a lot about practicing. Just practice, practice, practice. Getting to bigger numbers, different numbers, and so forth. It's all about practice. She's only 3 and left strong. Yeah, that's awesome. Oh, I don't know if you know about the preschool one. So I had a student that did the preschool one. It took him a little bit, and we started talking about like how to read the numbers and so forth. And then I also have it where I have like activities to do tracing and stuff. And there's also cutting. There's other activities that I have in my. I'm trying to publish everything that I do because I have some students that are 3 that just turned 4, and I try to make it more interactive. Oh, there was one. So there was one that I made that I just made, and what it was it was a puzzle. It was a puzzle, and this one was to count, like to tell me what numbers come before, what comes after, and I liked it because I wanted to make it like I wanted to practice like their motor skills, like cutting and pasting and gluing and stuff, and so this was one of my students' activities where it was like I have to I was going to publish this out, and so what it was is they had to find the number, what comes after the number. So this is the board, and then this is the if this is 1, no, this is 0, so then they had to find the number 1. I messed it all up. What is 1? So they had to find the number 1. So I have these sort of activities. I have to find the number 1, but I can't find it. Now I'm under pressure and I can't find it. So that's 3, that's 2, that's 1. No, I'm missing 1. Okay, I lost it. I think I lost it. Okay, but anyways, so this one was 8, right? So this one was 8, and then I had them find what the number 9 was. So I wanted them to understand what the relationship is. So then they would paste it. They would glue it. I didn't glue it because I didn't think about gluing. And then here this is 5. So the on the board is 5, and then they would have to find the number 6. So they found the 6, and then we do 1. This is 1, and then they had to find 2. Oh, this is wrong. Is that right? That's wrong. 9, 9. 6, 6. Uh-oh. Uh-oh. Something went wrong, Will Robertson. Something's wrong. Something's wrong. So this was this. Uh-oh. Maybe I'm doing it upside down. No, no, that's not right. 8. So that's 8. This is 9. Oh, this is 9. Oh, see, that's what it was. 9. I do 2 9s. Oh, I gotta redo that. Oh, I made a mistake. That's what it was supposed to be. Okay. All right. Well, anyways, that's my activity. So, there we go. I'm missing 2 numbers. Okay. Anyways, that's the activity. Oh, here it is. So, I got to redo this. Good thing I did it. That one. There we go. So, there's the one picture. Yeah. Anyways, so there was a cutting. This is a cutting one. And then I'm going to add it more. I'm going to add more. But then that's what this is. So, I have more activities, and so a lot of it is just counting, and then when they count they need to know what the numbers are, and it's just to reinforce what the numbers are and what the how to read the numbers, and then what these are. And do you list on TPT? I did list it on TPT. This one I did list on TPT, and if you don't need the beginning parts, you don't need to. And then I also listed on my website too. TPT is easier because you can break it up. So the TPT one is this one. So that's my store. This is my store. And then if you want to look for an abacus, you can get this one from my website. This one comes from my website. And then this one you can get at Daiso. But then there's the other one where you can get this one too. And then if you want to find my other books, it's under this. Yeah. So I'm trying to get it out there. I'm trying to, I'm trying to flood the market with abacus. All right. So there's hyphens in my name for the store if you wanted to. Yeah. So I was trying to do that too. I'm trying to also update more TPT. I just was kind of, because you know why I didn't do TPT so much. It was because it's hard to get ranked in TPT because nobody's looking for abacus. So that's why there's not a lot out there. But I'm going to start, because I'm doing more lives and people are starting to see me. I'm going to start publishing more on TPT and my website, and publish more books, just because now people are starting to see what abacus is all about. All right, so that's what this book is about, and we're going to actually go through the book a little bit. But the first thing we're going to do is we're going to continue how to count on the abacus. When we count on the abacus, what we need to do is we need to understand this is 10. What we did here is we had our place values. We have our ones, our tens, our hundreds, our thousands, our 10,000s. Now, if you look, we have 1, 2, 3, 4. All of the lower beats has a value of 1. Now, if we want to do 5, the top beat always has a value of 5. Excuse me. So we have 6, 7, 8, 9, and then 10. Notice 10 looks very familiar, right? But the difference is it's the place value. So we have a 0, we have a 1. We have a 0, 1. So we can do 20, 20, 30, 40, and then we have 50. Notice 50 is the same as 5, but just in a different place value. So then we have, so the next number is 11. If I did 11, it's just 1 and 1, just as we write. So the way the abacus looks is the way we write. When we write, this is what we do. And then we have 12. We have 1 and 2. 1, 2 is 12, right? So then we do 12, and then 13, 14, and then 15, 16, 17, 18, 19, and then 20. 21. Does that make sense? So then when we start going through, we could do 121, just as how we write. So when we write it, we could do 400, 456. We do 400, no, 456. And that's how we count on the abacus. When we start looking at the abacus, wow, I never knew math this way, but this is cool. Yes, thank you, Irvin. Yes. So it's very tangible and it's easy to do. It's simple to use and easy to understand. The idea is just to make sure you understand how to read the abacus. Once you learn how to read the abacus, then it's easy to do adding, subtraction, multiplication, division. And we can also do decimals, but it depends on time because I actually do have to go in about an hour. Um, Here. So when we start looking at it, well, why are we here? Some people might be asking, well, why am I here? If you notice, I have a little dot indicator. This dot indicator tells me that this is going to be my ones place. You could use this as your ones place, but if you notice, you would have to shift everything over. So when I shift everything over, I don't have any more hundreds. So I only have tens. This would be ones, tens, and then anything after that would be my decimal. After my decimal, right, this would be tenths, hundreds, thousands, 10,000s, and then 100,000s, right? A decimal sits between the two columns. When the decimal sits between the two columns, it doesn't sit on an actual place value. Does that make sense? So when we're looking at it, right, when we're looking at it, this is 0. I'm going to move it back, and I'm going to start using this decimal. Not decimal. This is not a decimal. This is a label. This is a label to tell me that this is the ones place. This is the ones, the tens, the hundred, the thousand, the 10,000. So when we look, I could do 2025. 2025. So this is the year 2025. Now it's a little bit to see. That's why I always add, the writing component, because sometimes it's difficult. It takes time to read it, right? So we have 2025. If you notice, I have 2 0. What? Why is it 0? Because none of the beads are touching the column. And then 2, and then 5. Anybody have any questions? We're going to continue on. Learning how to read the abacus. Let me know if you have any questions. But if you're looking for this worksheet, I do have this worksheet on my website, and you can get it for free. Download it. Okay, the link's in the bio. So again, what we're going to do is we're going to review. I don't have my other page. Where we're going to review. We're going to review. I have my other page. My other page is... Here it is. So let's do a little review. For those people that came in, what we're going to do is we're going to read the abacus. When we read the abacus, we do 0. This is 0. We want to make sure that all the beads are 0. So this is 1, and this is 1. 2, and then 3. Whoa, 3. And then we have 4. After 4, we have the value of 5. The value of 5 will always be the top bead. Because the value of 5 is the top bead, we can add 6. So when we bring it together, we want to bring it together like this. So when we move the abacus, you want to move your 2 fingers. We want to move it like this, 2. And then, 6, right? This is 6, and then this is 7. Notice I have 1 bead on top and 2 beads on the bottom, so this is 7. And then we have 8. 8 looks like that. If you notice, I take 1 bead on top and 3 beads on the bottom, and I add 8. And then we have 9. 9, and then some people would ask, well, what's after 9? Well, what's after 9 is 10, but notice 10 is still just the 1. 10 is just 1, but in another column. 10, right? 20. That looks like very similar to this. It just depends on what column we're in. That's why we had this. We have and it takes time to read it. So after we understand how to read it, I can, obviously go through. So we have 2, 2, and then this is 20, this is 200, this is 2,000, and then 20,000. And again, it's the same thing. This is 3, 30, right? 30, and then 300, and then 3,000, and then 30,000. I've always wanted to learn this. Can you do multiplication with this? If so, what does it look like? Yes, we can do multiplication on this. You want to see it right now? We can do it right now. But just so you know, Raphael, just so you know, you need to know how to add and subtract, right? First. But I can show you how to multiply. Everybody always wants to know how to multiply. I don't understand why everybody always wants to learn how to multiply first. It's like we jump through everything. It's like, just tell me how to multiply. It's like, well, you need to learn how to add. But that's okay. We can do it. Let's do it. All right, let's do it. Okay. So the first thing we're going to do is, let's do 47 times that by 3. So, good morning, Mark. So just so you know, but that's, I just giving you a caveat, right? Because people will be like, no, that's so confusing. That doesn't make sense. You know what I mean? Like, I don't want to get haters. I don't want to get haters because I'm jumping ahead. You know what I mean? I'm just letting you know. Oh, thank you for the hand heart. You know what I mean, Raphael? I'm not knocking it. I'm just saying if it gets confusing, it's because we jumped through it. That's all. All right. So the first thing we do on the abacus is understand what we're going to do. What we need to do is we need to understand what place value we're going to put our answer. The reason why is because when we on the abacus work on the when we work on the abacus, we want to go outside first. We want to count 1, 2, 3. So this is going to be our third column. When we have in our third column 1, 2, 3, we're over here. Now on the abacus, you need to know your multiplication fact. No matter what, you need to know your multiplication fact. So it really strengthens. So I have 3 times 4. 3 times 4 is equal to 12. I add my 1. I add my 2. Right now, notice the way I have it is I have 12. But if you look, I have 120. But I don't need to say 120. Why? Because the abacus takes it. The abacus helps me track it. I don't need to remember 112. So when I'm doing this, I just need to add my numbers. It's only helping me to track my numbers. So now my final one is 7 times 3, right? 7 times 3 is 21. All I got to do is add my 2 and add 1. That's it. So my final answer is, what's my final answer? Okay, Raphael, let me know. Do you know how to read the abacus? What is my final answer? I'll wait. What's my final answer? Oh, come on, Raphael. You can't be shy now. Yes! Tigered Mom, yes! Long time noob. I'm a long time noob. I feel it all the time. All right, yes, exactly. So the answer is 141. Oh, Raphael left. Oh, that's really... okay, good. You're still here. Yeah, but see, the thing is it's because it's very visual, it's easy to just move the beads, right? Hi, Manny, welcome. So it's easy to move the beads, and that's the thing that's why I started in the beginning. See, not Ken says I don't get it. That's because it's Raphael's fault. Okay, Ken, not Ken. Not Ken. What we're going to do first is we're going to read the abacus. To understand how to read the abacus, we need to understand that all the beads are touching all the beads, right? I'm telling you. I'm telling you. So we have to read, right? This is 1, this is 2, this is 3, 4. This is 4. Not Ken. Does that make sense? So when we do 4, after 4 is 5. All the top beat has a value of 5. When we have 5, we have 6, 7, 8, 9, and then we have 10. Notice 10 looks like 1, but it's in a different column. When we look at it, we have 10. So we have tens, ones, tens, hundreds, thousands, 10,000. Okay, so so after we look, and not Ken, I don't know if not Ken's still around, but you have to let me know. This is going to be 11, 12, 13. So when we read the abacus, we did 513. And then we do 4,513. We're going to continue on and we're going to start adding. We're going to start adding. Raphael, I hope you're here for the ride. So when we add, we want to do 2. Now notice what we're going to do is we're going to start moving the beads. As we start moving the beads, we need to understand, what are we doing? We are needing to understand how the beads are moving. This is so simple. Oh my God, I used to be so confused. Really? Ephraim? That's funny. Really? It's really simple to use, easy to understand. Easy to understand. Yeah. No, cuz I think what it is, people get confused because the teacher is confused. And really what it is it's just really about place values. Every column is a place value. So when you look at it, it's easy to understand. When you see this dot indicator, there's this dot right here. This is the indicator to tell me where my ones place is. Notice I have this ones place. So I could choose any one, like Pokemon, right? I choose you! But if I choose this one, then that means I gotta shift everything over and I have my ones, my tens, And notice I don't have any more hundreds. So when we're looking at our decimal, we want to try to know where our numbers are, how big our numbers are. So if you notice, this one is the previous question we had, and what we did is we counted our digits. When we counted our digits, we kind of know what we're looking for, right? So that's why I would start here. Why? Because when I counted, I have 3 digits. I have 1, 2, 3. When I have 3 digits, I know I'm going to be over here. If I use this as my digit, I'm like, then I can't do it. Because why? 1, 2, and there's no more 3. Does that make sense? So using the dot indicator will help you place your values, will help you track your numbers. So again, when we count, we do 1, 2, 3, 4. It's different. I've seen different models use the same process. Or is it just depends on the user? Actually, it depends on the question, Raphael. So this one is a 7-column. This is a 7-column abacus, right? 7 columns, right? And it's colorful because I like it colorful. Why? Because I've dealt with the gray one. I have dealt with the monotone one. This is a 13-column one, but it works exactly the same. This is 13 columns because size matters. Okay. Now the why? Because when we look at it, when we're looking at this, I'm sorry, I gotta do it like this. No, there we go. So when we're looking at it, right, it's exactly the same. But notice the only thing that's different is the amount of digits. When it's the amount of digits, then we can do bigger numbers. So usually it happens when we have like multiplication or division, and it's nicer because you can put all your information on the abacus. The idea to use the abacus is to use it to help you track. So when we're doing multiplication or even division, we actually put the dividend on the abacus. So when we look, we have 5. This is 5. See how it's the same? And then after 5, this is 6. So after 6, this is 7, and then 8, and then 8, and then 9, and then 9. So that's one abacus. This is called a Japanese abacus. After that, so if you notice, this is a 13-column abacus. If I wanted to, I can use the one over here, right? Remember I talked about the dot indicator. This dot indicator can be over here. So that means I would have my ones, right? My ones, and then tens, 100,000. So every group is a separator, right? If you notice every dot, every indicator, there's a separator. So I know I have my ones, my thousands, my millions, my billions, and my trillions. So after trillion, right? Does that make sense? It's nice that there's marked. And it's really interesting on how elegant this is. But if I wanted to track the national debt, the 13-column one doesn't work. I would have to get a bigger abacus, and this is a 23-column abacus. This 23-column abacus also has the same dots, right? If you notice, this is my ones, my tens, my hundreds, my thousands, my 10,000s. No, sorry. My ones, thousands, millions, billions, trillions. I don't know what's after trillion, and I didn't look it up. So there's after trillion and then 2 after trillion. And then notice that this is the one that I've had for more than 20 years. And then this one is made out of plastic. This one is made out of bamboo. They work exactly the same. 23 times crazy, right? They work exactly the same. The only difference is the amount of digits. That's all it is. So you could still do the same thing. We still need to do the same thing. We need to do 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it's all exactly the same. It just matters like how many digits you have. So size does matter. And then this one specifically has a reset button, which is neither here or there. It's just kind of, it's gimmicky, really, because you could just easily like tilt it and then move all the beads up. And then, thank you for the follow, Mark. So then this one is made out of plastic, and then if you wanted to, this one's actually, you can get it from Daiso. You can get it from Daiso. I don't know if you know how to spell Daiso. You can get it from Daiso. Somebody was able to get it for like less than $4, right? It's up to you, not a problem. So then this one is 13. My old chem teacher in high school says size matters, and chuckled, makes me, yeah, right? Because size matters. Exactly. It's just funny. And then and my husband's like, no, it's how you use it. I'm like, you would have to string like 5 of these if you wanted to use it. Anyways, So then this is the Japanese abacus. What that means is if there's a Japanese abacus, there's a Chinese abacus. The Chinese abacus was before the Japanese abacus, but the Japanese made it more efficient. What does that mean? Well, if we look, here's the Chinese abacus. This is the Chinese abacus, and it works kind of similar. It works similar. So we have our ones. We have 1, 2, 3, 4, 5. We have 5, right? That's fine. But then because we have 5, we have to trade it in. After we trade it in, we have to do that. This is 5. This is always 5. So that's 5, right? But notice in the Japanese one, we don't have 5. We have to go to here to 5. So this is what makes this is what makes the Japanese one good. The Japanese one more efficient. Good morning. Did you already go to your interview, Beal? So we have 5. We're trading it in. When we do 6, 7, 8, 9, and then 10, again, we have 5 here. We have to trade it in for that. Every top bead is a value of 5. So when we look, this is the top bead of value of 5. We have 10. But notice this breaks my brain. Why? Because this is no longer part of this is no longer part of place values. When we look at it, I want it to be proper, right? No, I'm currently waiting. Oh, good luck. Good luck. So what we're doing here is we have 10. Now this is breaking my brain because we are no longer using the place values, right? We're no longer using the place values, so we have to do another trade in. I was like, okay, well, whatever. But the abacus, on the Japanese abacus, they made it more efficient that there is no trading. This is 5, this is 10, no matter what. You can't make 10. But the other interesting thing, and the user was able to realize that you can do 15 on one, we can do 15 on one column, right? So if we count 1, 2, 3, 4, 5, that's 5. 6, 7, 8, 9, 10, that's 10. 11, 12, 13, 14, 15. And so it gets really confused. It can get really confusing really quick because what happens if I do this? Well, now we have 25, and I have to break my brain, and that's not good. I don't like my brain to be broken. So I would do trading in. I would trade it a lot. I would trade. So this is what it would look like. For me, that's what it would look like, if that makes sense. So this is the thing about the Chinese abacus. Now, in the grand scheme of things, there's still people still use a Chinese abacus, but it's not as many as people who use the Japanese abacus. The Japanese abacus is more efficient, and people find it more. And then you see a lot of the numbers. I'm sorry, you see a lot of the people that do this. You see all the kids that do this, and some of them are like this, and they're like that, and like that's really dramatic. Really, you don't need to do that. Why? Because you're only doing this. You can't even see from my face that I'm doing this. I don't know why they're like doing this, but whatever. So on the videos that you see, that's what they're doing because they're recognizing the beads in their mind, and because they can see the beads in their mind, they're actually moving the beads in their head. Can you do another problem? Yeah, not Ken. Let me do another problem. Like, oh yeah. So I will talk about. What am I going to talk about? Oh, I got to keep that up. Okay, sorry. Let me clean up a little bit because it gets messy after a while. All right. So the first thing we're going to do, when we look at it, okay, here's the thing. When we look at it in Abacus, we actually don't look at the result. What we look at is that's why they do that. My mind was just blown. That's why they do. Yeah, no, when they're doing this, that's just being dramatic. They don't need to do that. Okay, so what we're doing here is we're going to understand how to move the beads. When we understand how to move the beads, the biggest thing is to know how to move the beads and what the add-in is. Why? Because we in the abacus world do not focus on the result. It's like the destination. We don't need to know about the destination. We know about the journey, right? It's all about the journey. Life, abacus life. Now abacus mimics life. Why? Because now we're talking about the journey. We're talking about marry the process and divorce the result. Sorry. I got jokes. Okay, so that's one of the things is to make sure we understand how to get the process, right? So what we're doing here is we're learning how to add a 1. That's easy. Of course it's easy, but it's all about how do you wax on and how do you wax off, right? So what we're going to do, right? This is Karate Kid. We need to know the basics. We need to know the fundamentals. In Abacus, this is the basics. This is the fundamentals. So when we're looking at it, we want to add let's do 5. When we add the 5, we want to add the 5. We want to add the 1. Notice we're focusing on the 1. When we focus on the 1, we're only moving the 1 bead. It doesn't matter if it's this bead, and it doesn't matter if it's this bead. As long as you're moving the 1 bead. Oh my gosh, Biel, thank you so much for the heart and the team cheers. Whoop whoop. Right? So when we have 7, right, and we want to add 1, we're just moving the 1 bead. That's all we're doing. See, it's not, I'm not doing that. I'm not being dramatic. I'm just moving my one thumb. That's what I'm saying. I don't know why the kids do that. So anyways, so we have 9, no, we have 8. And then we have 8. Notice I'm going to move to the horizontal bar. When I move to the horizontal bar, that means I'm adding. When I move away from the horizontal bar, I'm subtracting. So now we know how to add and we know how to subtract. And that was one of the things that the kids were having problems with. So some of the kids were having problems because they're like, I don't know how to subtract. I'm like, come on. All you got to do is just take it away. All we're doing is removing. So now when the beads are holding hands, when the beads are holding hands, then that means they're all counted. When the beads are not holding hands, then they're no longer counted. So when we do this, we can go to the next one. So let's do 2, right? We have 2, we have 5, we add 5, and then we add 2. When we add 2, we're going to bring these 2, and they're like 2 peas in a pod. So 2 peas in a pod goes to the horizontal bar. The horizontal bar is what counts. Horizontal bar counts these beads because they're all holding hands. When I want to add 2, it doesn't matter what 2 as long as it's 2 beads. So I'm adding 2 going to the horizontal bar. When I subtract, I want to take it away from the horizontal bar, right? It's all about positioning on the abacus. That's all it is. As you position the abacus, right, you go forward, you go backwards. It's just like walking, right? You go forward, you go backwards. You walk forward, you walk backwards. We know how to walk backwards. I'm hoping we all know how to walk backwards. So we have, 7, and then we plus the 2. So notice, right, we have activities, and then we have the plus 3. When we add the 3, it's the same thing. I'm going to do this one because, it's always nice to start with the number. But notice when we do it, we have 5, and then we want to add 3. When we want to add 3, again, it's these 3 beads. It doesn't matter which 3 beads it is, as long as it's 3 beads. So if I had 6, right, I'm going to add these 3 beads to make 9. Afterwards, what we do. So what are we going to do is we understand this. Now, what's going to happen? Well, after we know how to 4, there's not very many questions with 4. Why? Because this is all 4. So it's either 0 plus 4 or 5 plus 4. So 4 is kind of easy. There's not a lot of questions with 4. Then obviously after we add, we learn how to subtract, and then that's what this is. But I've already talked to you about that, right? As we go through, well, what about 5? Well, that's what we're doing. We're going to go to 5. Not a problem. But wait, there's more. So when we add the 5, again, it's going to the horizontal bar, and we go away from the horizontal bar. Notice it goes 2. So you're coming down, right, from the top bead, and you go up to subtract. So that's why I don't use up and down. I use to the bar and away from the bar, if that makes sense. Go to the bar and away from the bar. When I do 6, I go to the bar. When I want, hey, Sir Patrick, welcome back. So I want to go to the bar. When I go away, right, when I minus, I want to subtract it. So when I do 7, I'm adding 7, and I want to subtract 7. Does that make sense? So I'm going to go away from the bar or to the bar. Okay. Anybody have any questions? Anybody have any questions? And again, it's a 6. We did 7. We did 8. Okay. No questions? Really? Come on. This is a boring. Good morning, everybody. Hey, Ash. Good morning, Ashley. No questions. Okay, all right. Now, you know what? If there's no questions, then that means nobody's really thinking. Why? Nobody's really thinking because what happens when there's not enough beads? What? What do you mean what happens? Can you do anything with variables? Yeah, we're going to get into it right now, actually. So, in Abacus, we actually have this thing called formulas. What is a formula? The formula is a thing. Sorry, I have to move it. Okay. How do you do more than 4? Exactly. It's just a finite number. What about irrational numbers? If you can show me a physical object that has an irrational number, then you can do it. Can you do negative number? Can you do a negative answer? Chainsaw, if you can show me how to negatively take away something that's a negative number on the abacus, right? I mean, doesn't make sense. The only thing we can do here is positive numbers. Positive, only positive, no negative. Everything needs to be positive. But it's logically thinking, right? Like on a calculator, because it's just a bunch of digits. But on an abacus that's physical, how do you do a minus? This is not it's not the ground and we dig a hole, right? You can't dig a hole and know what the negative is, if that makes sense. I'm not knocking it. I'm just like trying to think about it. When you logically think, how do you do a negative number? You can't. How do you do a negative of a physical thing? Right? You could take it away. So if I had more, I can take it away. But after zero, how do you do negative? That doesn't make sense to me. So variables. Oh, we're talking about variables. Okay. So the first thing we're going to do is we're going to understand. Let's do three. You know what? We're going to do three. So we're going to do three. Now, if you notice, school teaches kids, right? School teaches kids this. Abacus only does arithmetic. Does arithmetic happen with negative numbers? It can, but then you go into imaginary, right? Irrational numbers. So unless you can show me like a physical number that's irrational, right? Or can you show me what a negative answer, a negative physical answer, then I can show you how to do it on the abacus. But if you can't show me, you know what I mean? I'm not knocking. I'm just that's what I'm trying to like logically think, if that makes sense. I don't know anybody else. Okay. So in school we're teaching the kids this. Sorry, I dwell on things. Okay. So yeah, how do you subtract 3 from 7? Yeah. So that's what we're going to do. We'll do that. Okay, so the first thing we're gonna do, we're gonna understand that this is the thing, right? This is we're trying to make a 5. What somebody said 5 rule. So we're kind of trying to make a 5. What now? These are the ways to make a 5. Why are we doing this? Because we don't want any freeloading numbers. No freeloading numbers. What we're gonna do is we're going to take 7 and then minus the 3. What's gonna happen is if you notice, 7 minus the 3. So to set this up in order to make sense, you know what? I'm going to do it the other way. I'm going to do 4 first, and then we'll do 3, because it makes more sense to do the plus, because it's easier to show the plus. So we have 3 plus 2 is equal to 5. Notice that we're trying to make a 5. The reason why we're trying to make a 5 is because we want to utilize this 5 bead. Because we're trying to utilize this 5 bead, we want to isolate the variable. When we isolate the variable, so the question is 4 plus 3. When we do 4 plus 3, we want to isolate the variable. This is the variable we want to isolate. It's very similar to x plus 2 equals to 5. So when we look at it, we're trying to isolate this variable. So what we do is we want to make the 3 by itself. When we make the 3 by itself, we want to say 3 is equal to 5. But wait, 5 is too much. So what do? We have to subtract 2. Well, what does that mean? Well, if you notice, I have the 4, right? And this is my formula. I'm going to add the 3, but notice with my formula, it's telling me directions. I want to add the 5, and I want to take away the 2, and that's my answer, 7. Does that make sense? So what's going to happen is, round and ready, if that makes sense, now we can do the subtraction, because we built a foundation that we know how to add. We always start with adding. We don't start with subtraction, right? Even with school. What the F? Yeah, that makes sense, right, Ashley? Right. So what's going to happen now, because we know how to do a formula, we're building our information, we're building our concept, we're compounding our interest, we're compounding our knowledge, right? We know how to do adding. Now, after we add, what we're going to do is we're going to subtract. Now we can do subtraction, and the idea for subtraction is 3 minus 2 is equal to minus the 5. Wait a minute, you said you can't. I'm like, no, but this is still just a concept, right? I'm just showing you the concept. The concept is, if I want to isolate this, and the question is 7 minus 3, right? 7 minus 3, but I have this formula. I have this concept in my head. What I want to do is minus the 3 is equal to minus the 5. That's too much. Because this is too much, I need to add 2. So if I have my question is 7, and I want to take away 3, I cannot take away the 3. To take away the 3, I have directions. This is directions. They give me directions. The directions is minus the 5 plus the 2. So my final answer is 4. Does that make sense, round and ready? Hello, Connor. How's it going? Wow, 25 people. Woo! Right? Does that make sense? Ashley. I know Ashley. Ashley knows. Ashley knows. Because Ashley's been here for a while, right, Connor? Yeah. Does that make sense? Or are you don't understand how to read the abacus? because it helps if you know how to read the abacus, right? So I don't know if round and ready. I've been, yeah, right. That's why I was like, no, Ashley knows. Of course, it makes sense to Ashley. She took the red pill. I'm understanding it a little. Okay, so let's do a little review to make my husband understand this. I bet to make that, don't think of minus five as a physical. Yeah, exactly. Don't make, well, it's what we want to do is we want, is this becoming a requirement for elementary students? No, but I wish. You know, so Bill, you might want to try use like a nickel, right? And you know what? I don't know. You're right. I don't know. It could be that you want to trade in the nickel and you want to give me a nickel, right? I don't know. Um, so Raphael is no, what they're using in regular school is like a bunch of other math manipulatives, and nobody knows how to use the abacus. So I'm here to teach the world. I'm here to spread the good word of the abacus. So, oh, so sorry, Connor. So Connor is, this is how we read the abacus. We go one, we have two, we have three, and then four. Bro went to work and you're still teaching. Rob. So, four. This is four, and then after four we have five. Because this is a value of five, right? The top B will always be a value of five. Connor. I'm hoping Connor's still around. So Connor, this is five, and then this is six. After six is seven, eight, nine. Notice we have our place value because we have a place value. This is the ones place. We want to do 10. When we do 10, we look at this. It's a 1 and a 0. Oh, good, you're still here. Because, you know, people come and go, and I'm like, ah. So when we look at it, just as we write, sorry, I'm just trying to get my papers. So just as we write 10, we have a 1 and a 0. We have a 1 and a 0 because we have a 1 and a 0. That's 10. So then what's after 11? Well, 11 is 1 and 1. 1 and 1. It's easy, right? 1 and 1. And then 12 is 1 and 2. Does that make sense? So whatever we do here, this is 9. This will always be 9 no matter what. This is 9, that's 9. These are all 9s. It just depends on how you read it. So when I do this, right, if I do that, this is all 8. If I do this, this is all 7. If I do this, this is all 6. If I do this, this is all 5. If I do that, that's all 5. This is all 5. It doesn't matter. It just matters on the place values, right? So just as I said here, there's the ones, the tens, the hundreds, the thousands, the 10,000. So if I said 5, right, this is 55,555.55. Yep, that's it. That's it. That's how you read the abacus. It's the easiest. It's easy. Simple to use. Simple to use. No, yeah, simple to use, easy to understand, right? Easy, right? So then when we start going into like adding and subtracting, that's what I was doing. And so when we were talking about it, we were just reviewing what happens when there's not enough beats. So the big thing is when we're adding on the abacus, right, we can add specific things. 2 plus 7, when we add 2 plus 7, all we got to do is add the 7. This means that that I haven't, the question is do I have enough beads? The big question is always, do I have enough beads? Yes, I have enough beads. I'm going to add 2, right? I'm sorry, I'm going to add 7. Do I have enough beads to add 7? Yes, I'm going to add 7. The formula happens, these formulas happen when we don't have enough beads. When we don't have enough beads, then we start using the formula. We start utilizing our numbers. We start utilizing the 5 because there's no freeloading numbers. I don't want freeloading numbers. See, I only tell these jokes because they're all adults. Because the kids don't understand what a freeloader is. Right? So what's going to happen is we have 3. We added the 3. When we add the 3, right, how do we do it? Well, if you notice, we have 4, and then we want to add the 3. When we add the 3, there's not enough. I have my formula. My formula is giving me directions. And that's the beauty thing about it. I want to add the 5 and take away the 2. This is the beginning steps of understanding how to do things, right? So then after we add the 3, we know how to minus the 3. Look, it's the same concept. But wait, there's more. Because after adding the 3, right? Let's say we have 3, and then I want to add another one, right? I want to add another 3. Oh, maybe I'm going to go, let's do, so we do have another question. If we have another question, let's say we have 8 plus 3. Wait a minute, I know 8 plus 3, right? So if we do 8 plus 3, we do 8, and we want to add another 3. When we add another, those formulas comes with a list of combinations that add up to 5. Yes, you just picked the right one. No, it's not picking, it's picking the scenario, right? It's all about figuring out what you're trying to do. That's why you need to know that's why you need to understand your add-in, right? These formulas, yeah. So then that's what this is. So we have our specific formulas. You're right. You're absolutely right. So we have our formulas. We have the 5, the 4, the 1. Nope, nope, nope. We have this one. So we have the minus 5, and then we have the plus 5. I didn't do that. I gotta find my numbers. I just started. Where is it? I don't do it. Where is it? Anyways, minus 5 plus the 5 plus the 1 plus the 4. Okay, we'll just do that. Right. So these formulas come from the list of combinations that end up 5. Yes, they do. So if you look, we have plus the 1. So when we're looking at it, it's really about how to make a 5. When we learn how to make a 5, there's all these numbers that we have just to make a 5. We don't want to do negative. We don't want to do 6 minus 1. We don't want to do that. That's not a pair. What the pair is 4 and 1 and 1 and 4. These are the pair. This is one pair. And then this is another pair. These are the only combination for this 5, if that makes sense. So when we look, we have 1 is equal to minus the 5 plus the 5 minus the 4. 2 is plus the 5 minus 3. 3 is the other way, right? Plus the 5 minus 2. And then 1 is plus the 5 minus 1, if that makes sense. So then we have the minus, right, is the opposite. The opposite is the same way, it just goes reverse. So we want to minus the 1. When we minus the 1, we just do this. We added the 4, take away the 4. So now we're talking about number patterns. We add the 4, we take away the 4. We add the 4, we take away the 4, right? We add minus plus the 5 minus the 1, we take away minus the 5 plus the 1, right? And then you just pick the right one. Yes, you pick the one that you need, right? Because it's all about understanding how to solve the problem, right? We don't just pick anything. We have to pick the specific one, and you're absolutely right. So here's the next question: is 8. When we do 8, I want to add the 3. Well, I don't have enough beats to add the 3. Wait, I know. We're going to add the 3 is plus the 5 minus the 2. But no, can't do it. You can't do plus the 5 minus the 2. Why? Because you can no longer plus the 5. So what do? Well, we have another set. How to make a 10. This is a very common thing, right? In school, we teach the kids how to make a 10. When we make a 10, look at that. This is the pair. 3 and 7. 3 and 7 is a pair. So what we're going to do is we're going to add the 10. So notice what we're going to do is we're going to do 7 plus 3 is equal to 10. Now this is very familiar, right? This is a pattern that we're seeing. Wait, I know this. Yeah, you do. Because when we isolate this variable, all we got to do is move this to the other side. 3 is equal to plus the 10 minus 7. So now it's directions. Again, they're giving me directions. I don't need to beat around the bush. I'm going to plus the 10. Plussing the 10 just means the one column over. Plus the 10, and I need to take away the 7. When I take away the 7, I'm just doing this. I take away the 7. So my final answer is 11. That's so easy. It's easy because we understand. Hey, Dean, welcome back. It's been a while. Does that make sense? So yes, Joe. Oh, good. Okay, good. Okay, good. That makes sense, right? So now we know how to add. We know how to subtract. Do we know how to subtract? Well, yeah. Guess what we're going to do? Because we know how to add a 3, we can subtract a 3. Again, it's the same pattern. Oh, oops. It's the same pattern, right? They talk about patterns in school. They talk about patterns in math. In Abacus, we show you the patterns. In school, they don't show you the patterns. They just say, oh, it's a pattern, it's a pattern. It's like, well, show me what the pattern. Show me the pattern. Right? So now we're having a pattern. Oh, I've done this before. So what? Minus 3 is equal to minus the 10 plus the 7. When does that happen? It happens when I need to, let's see, I don't know, 12. We do 12. Let's do 12. I want to take away 3. 12, take away 3. 12 take away 3, I have it here. Minus the 10 and add the 7. Plus the 5 and 6 and then 7. I add the 7. And that's it. My final answer is 9. So that's it. That is the secret to adding and subtracting. You need to know how to plus a 10, plus a 5, minus the 5, and minus the 10. These are the 4 things you need to do. To do any addition problem, you just need to know how to Tetris your way through. That's it. You just need to know how to Tetris your way through these 4 formulas. Once you know how to Tetris your way through the formulas, then everything is golden. So, but I think the reason why people are so fast because they recognize the numbers, because they work with the numbers and they practice the numbers often, right? As you go through and understand numbers, you'll see that there's patterns. Here's what I just said. So in the addition table, here's my addition table. When we look at it, we started off with simply adding, meaning that we had enough beads. After we had enough beads, right, that's what this blue, greenish, whatever, right? That's what this is. And then we did the 5. This is the adding of the 5 because we don't have any more beads to add, right? If I did 4 plus 4, I need to add another 4. That's what this is. That's what these are. These are adding of the 5. Thank you, Ash. Thank you, Ashley. So then after adding the 5, we have to add a 10. Adding the 10 is the next thing, right? That's the next concept. And that's what I just showed you. So what's going to happen is, but wait, there's more. What does that mean? That's what this white thing is. This white thing here is called a 2-step equation. This is where we start Tetrising, right? Not alienating, not alien and predator kind of invading. It's Tetrising, right? Tetrising everything together. So it all depends on how it all gets Tetrised. So what does that mean? Okay, let's work with this. Let's do 5 and 9. 5 and 9. What? 5 and 9. So when we look at it, oh, okay, good luck, Bill. Good luck. Let me know how it goes. Okay, so let's do 5 and 9. When we do 5 and 9, we want to, okay, so the question is if I look at, oh, you know what, that's fine. 5 and 9. So in school, they're like, okay, this is a whatever. This is a commutative property. I'm like, no. We can't do this in Abacus. Why? Because it's the add-in that we have to focus on. The add-in is what differentiates what we're trying to do. So the first thing let's do this one. Let's do 9 first. We do 9 and we want to add the 5. We know when we add the 5, it's plus the 5 is equal to plus the 10 minus 5, right? So we want to plus the 10 and we take away the 5. Okay, fine. Then my answer is 14. They're the same. No, they're not the same. Why? Because now it's different. Now we have a second add-in. What does that mean? Well, we do 5 and then we want to plus the 9. When we plus the 9, we know when we plus the 9, right? We plus the 9 is plus the 10 minus the 1. Okay? So we plus the 10 minus the 1. We want to plus the 10. So we plus the 10, but look, we cannot take away the 1 anymore. So this is what we call a 2-step equation. So because we cannot take away the 1, what can we do? We know how to minus the 1. We can utilize our freeloading 5. Does that make sense? Because we can utilize our 5, we know that minus the 1 is equal to minus the 5 plus the 4. Does that make sense? So what we're going to do, we're going to minus the 5 plus the 4, and my final answer is 14. So this is what we talk about critical thinking, right? Because the idea is we know we have our formulas, we know we have our foundations, but now how do we do it? How do we fit them all together? Does that make sense? So, Joe, when we look at it, it's exactly what it's exactly what you said. You have to pick the right one. You don't want to go too much, right? Because it doesn't help. But you don't want to go too little because it doesn't help. You got to get like Goldilocks. It's got to be just right. And right? And the thing is as you do this, it can scale. We can actually do, it doesn't matter where you are. It doesn't matter if we did 50, right? It doesn't matter if we did 50 plus 90. 50 plus 90 is still the same. Plus the 10 minus the 1. Minus the 1 is minus the 5 plus the 4. When we talk about it in the different columns, it's still going to be this just the two columns. We don't look at the whole thing. But I know in mainstream math, they say, okay, 50 minus 90 is equal to, okay, we got to make sure we have 100, and then we got to do, you know what I mean? So in mainstream math, they're writing it all out. But in Abacus, we don't need to write it out because it tracks it for us. Because it tracks it for us, we don't need to say 140. We just move the numbers. We do not say 90 take plus 100. We do not say that. Minus 10. We don't say that. What we say is 9 is equal to plus the 10 minus the 1. That's what we say. We don't do this because then it gets complicated, and Abacus is not about. We want to strip away the complications, right? We take it into manageable chunks. This is a manageable chunk. This is not a manageable chunk because it's just too much. Could we do multiplication on the Abacus? Yes, Dean, we can do multiplication. Okay, so yeah, I mean, now since people are understanding how to add, right? People understand how to add and subtract, it makes sense. So now we can start doing multiplication. When we do multiplication, there's a set of procedures that we need to do. What do they call it? They call it procedure fluency. And I'm like, they're making up words. They're making up like fluencies. I don't know why they're making it up. It doesn't make sense to me why they're making it up. All right. So the first thing we're going to do is I don't know what procedural fluency means. 76 times that by 2. Let's do that. So what it was going to do is the same thing. We're going to figure out our place values. When we figure out our place values, what is our place value? Our place value is, survey says, what is our place value? How do we know? We count our digits. 1, 2, 3. Right? We know we're going to be in the third column. 1, 2, 3. All right, we're here. So now what are we going to do is we're going to do 7 times 2. 7 times 2 is 14. We had our 1, we had our 4. Okay, see, this is where now we know the foundations of adding and subtracting. Now it's not as difficult, right? So 6 times 2, if I can write 6, is 18. I add the 1, I add the 8. I add the 1, I add the 8. Notice I need to add the 1. To add the 1, I don't have enough beads to add the 1. Now I know what to do, right? I know that when I want to add the 1, I need to plus the 5 minus 4. So I'm going to plus the 5 minus the 4. And then, oh, thank you, 2. Yes. Yes, thank you, 12. I was thinking 3. Yes, thank you. That's still it, though. Thank you, Axel. Right, so my final answer is 152. And that's multiplication. We can do more, but also understand that because now we have a foundation of how to add, it's not as scary. It's not as scary to multiply because now I know you guys know how to add and subtract. It's always about, knowing what you know. Know what you know, right? Thank you. Thank you, Axel, for the help. Frequency sounds frequency sounds way more difficult than it looks. Okay. Can we do another multiplication problem? Yeah, not a problem. Let's do another one. Let's do another one. Okay. So, but again, understand that when we do multiplication, you need to know your math facts. That's the hands down, right? The hands down is that you need to know your multiplication fact. Okay, we'll do this one. We'll do this color. So we could do 95 times that by 9. So we do, where's my abacus? Again, it's the same thing. And we're going to go here. I'm going to go here. Let's go like that. Okay. So 1, 2, 3. 1, 2, 3. Right? And then we do 9 times 9 is 81. 80, whoa, 81. And then I'm over here. Right? And then 9 times 5 is 45. I add 4. I need to add the 4. How do I add the 4? Not enough. Not enough. So what do? Plus the 5 minus the 1 and then add the 5. So basically you need to know the answer of the question, use the abacus. Basically you need to know the digits. That's what it is. You need to know roughly how big your answer is going to be. That's what that means. Yeah. Yeah. So no matter how big the number, no matter how big it is, you need to know how big the number is. That's what it is. So so basically you need to know how big the number is, the number how big the answer will be. So we're kind of roughly guesstimating we're going to be around here somewhere, right? We're going to be somewhere around these two beats, right? So that's why we did this. You can have more or you can have less, right? So this is going to be kind of like in the middle. But yes, it's always good in the in abacus world, we need to roughly know where our answer sits. So it's easier for us to understand. Does that make sense? Okay. So we can do another one. These are okay. Let's see. We do 38 times that by 7. It's the same thing, right? We do 1, 2, 3. How do I know? 1, 2, 3. 1, 2, 3. And then what are we going to do? Now, when you look, if you noticed, I don't know if anybody's been paying attention. What I do is I go outside first. I go left first. I go left outside. I do left first and then I go in. So after this we can do two digits. So we have 7 times 3 is equal to 21. So we had 2, we had 1. And then 7 times 8 is 56. 7 times 8 is 56. So add my 5 and then I add 6. So my final answer is 266. Yeah. Let me know if you have any questions. So, but it's the same thing. So let's do two digits. Hey cat, that the hat that kisses. Okay. Let's do that. We're gonna use the back of the book because nobody uses the back of the book. So let's do another one, right? We can do 39 times that by 64. It's the same thing. Now, can you tell us the values of the colors? Hi, cat. Oh, the values of the colors actually means nothing. It's all about the beats. Everything on the lower beats is a value of 1. So what does that mean? Anything underneath the horizontal bar. This is the horizontal bar, and this is what tracks the beats. This is what tracks the beats. So when we count 1, 2, 3, 4, notice all these beats are 4. So we have 4 and then 5. The value of 5 will always be top. Because we have the top to be a value of 5, we can start adding 6, 7, 8, 9. If you notice, this is 9. When we look, 9, 9, 9, 9, 9. Is there more than 9? Yeah. There's 10, but 10 just means that we're going to go here. It looks very similar to this. So if you notice, when we look at it, it's all about place value. When we have ones, tens, hundred thousands, 10,000, we have 1, 2, 3, 4. Then we have 10, 20, 30, 40. And then we have 100, 200, 300, 400. Make sense? But it's not about the colors because when we talk about this, there's no colors here, right? Move the brown bead. Brown bead, they're all brown. So it's all about the placement of the value, placement of the beads. When we count it, it works exactly the same. 1, 2, 3, 4, and then we have 5. The top bead will always be the value of 5. So we have 5, 6, 7, 8, 9. Cat, did that make sense? Yeah? Wow, what math are we doing on such a large abacus? It's, honestly, it's just the bigger numbers, right? So it's all about the numbers. How big your abacus is how big the numbers are. So if you're trying to track the national debt, right? You're going to need a bigger abacus. You're going to need the 23 column. it's all about the digits. Wait, I want to see how to use this equation. I want to see how to use it with the equation. This is so cool. What equation? The this question? We're doing multiplication right now. So the luminosity. Yeah, we're doing multiplication right now. So, Kat, did that make sense with the values before I continue? Yeah, Joe. Joe, it doesn't matter how big. It just matters on how big your question is. So if you have, so if I started here, then I have 13 digits, right? My ones, thousands, millions, billions, trillions. And then if I wanted to, right, I have the 23 column one. It's the same thing. I have my ones, my thousands, it's the same thing. It's just depending on how big the number is. So like a lot of this is usually used probably like competition math. Why? Because the numbers get really unruly, and then they just go through the whole thing. But I think for what we're doing, I think 13 is plenty. All right. So I don't know if Kat is still here. That Cat the Hat Kisses. I don't know if you guys are still here. All right, but I'm going to continue on. What we're going to do is we're going to do multiplication. Again, we're going to find out our digits. When we find out our digits, we need to look at it. We have 1, 2, 3, 4. Notice that there's 4 columns, 4 digits. So I know I'm going to be somewhere around here. 1, 2, 3, 4. I know I'm going to be somewhere around here. Whether I'm here or here, it doesn't matter. It just I need to know the ballpark, right? I guess that's why they call it ballpark, right? Now notice when we talk about it, we want to do left first. That's why we do 6 times 3. 6 times 3 is equal to 18. I add 1, I add 8. 6 times 9, right? 6 times 9 is 54. I add 5, I add 4. Notice I don't have enough beats to add the 5. This is why it's good that we know how to add on the abacus. When we add on the abacus, I want to add the 5. Adding the 5 is equal to plus the 10 minus the 5. So on a plus the 10, I want to take away the 5. And then I'm done. No, I'm not. And then I add the 4. So don't forget to add the 4. Now remember, what we're doing is we're doing multiplication. We're done with this. We're done with that, and then we got to do the next one. We have to count again. 1, 2, 3. So when you go 1, 2, 3. Now we go 3 times 4 is equal to 12. Add the 1, add 2. There's not enough beats to add the 2. See how Abacus lets me know what my restrictions are? It tells me the barriers and the guidelines. So 2 is equal to plus the 5 minus the 3. I want to add the 5 and I'm going to take away the 3. And then what? That was 3. Now we got to do 4 times 9. 4 times 9 is equal to 36. So I want to add 30 and I want to add 6. So I'm going to add 3, I'm going to add 6. And my final answer is, survey says, final answer is 2, 4, 9, 6. You lost me. Hi, Dolce. 9, 5, 6. Yes, right, Dean? So does that make sense? So what we're doing is when we do this, you want to make sure you go from left and then right. Right? Okay, good. It's right. Yeah, it takes some time to understand, but don't forget we needed to know our addition before we go into multiplication. So that's why when we jumped ahead, it was just like, okay, we can do it. It's just some people might get lost. So when we do multiplication, and obviously if we do multiplication, we can do division. However, I am sorry to say, but I do need to leave. Dolce, dolce, dolce. 1, 2, 3, 4. If you're still here, let me know. This is 4. How do I know? Because it's touching the horizontal bar. Because it's touching the horizontal bar, because this is touching the horizontal bar, I want to do 4. After 4 is 5. Do you know how to count it on the abacus, Dolce? Before we start asking questions about the minus the 5 plus the 3. So I feel like I'm in class right now because it feels like 25 classes. I'm like, yeah, oh, hey, Brenton. Yeah, it is a little bit like class. And you know what? It's math in the morning. You guys are crazy to be here on voluntarily learning how to do math. So, Dolce, are you still here? So we do 5 because this is 5. We have 6, 7, 8, 9. Do you know how to read the abacus? After 9, we have 10. How do I know that this is 10? Well, we want to do is we want to understand that we have place values on each of them. When we do place values, right, we have ones, tens, hundred, thousands, 10,000. Does that make sense? Dolce, are you still here? Please let me know, because if not, I'm going to continue on. Okay, so we have 10, 11. Okay, good. So does this make sense? What we're doing is we're reading the abacus. When we read the abacus, then you'll understand. But the first thing you need to do is understand how to read the abacus, right? So good. Thank you so much, Dolce. So when we do it, 9, right? We have 9. This is 9. All of this is 9. We can do 9, 9, 9, 9, 9. This is all 9. Because this is 9, there's 10. Well, what's 10? Well, if you notice, 10 looks like this. 10 looks like this, but this. The difference is just a place value. So we have our ones, our tens, our hundreds, our thousands, our 10,000s, and then anything between, right? This right between is our decimal, and then we have our tenths and our hundredths. So what we're doing is we're learning how to read the abacus. After we read the abacus, then we can start moving the beads. After we knew how to know the beads, then we can start figuring out what happens when there's not enough. So yes, exactly, exactly. So we do this, right? This is 9, 9. And then there's a point. If there's a point, it'd be 9, 9. So what would be? It would be like this. It'd be 99, comma 999 decimal 99. That's what it'd be. Exactly. That's what it is. Exactly. And so if you wanted to be more numbers, then you have to get a bigger abacus. This is a 13 column abacus. This is only a 10. This is only a 7 column abacus. Yes, exactly. So good. Make sense? When we're doing and then the thing is understanding how to move the beats. Yeah, right. No, but that's what I'm saying. Like the questions are great. I like the questions, but the thing is it's too far. It's above, not above your pay grade. It's just above the knowledge that you have, because we didn't talk about it. Or yeah. Does that make sense? So, I am now just obsessing. Okay. Hey, Lady E, welcome back. I am actually going to leave though because I have to get ready for class. But if there's any other questions, let me know. I will be on live probably later today. But thank you guys, everybody. What's 11? Oh, okay, let's do that. Okay. So we have, no. Okay. 1, okay, before I forget, before I do, okay, 7 minus 9. Yeah, not a problem. Yeah, not a problem, Dolce. Okay, so Queen, I'm sorry, Lady E, 1, 2, 3. What we're going to do first is we're going to minus the 7. We minus the 7, do we have enough? We don't have enough. What do we do? We minus the 7, right? Minus the 7. We don't have enough. So what do? We have to minus the 10, right? So we know that when we minus the 7, it's equal to minus the 10 plus the 3. So we minus the 10 plus the 3. We minus the 10, we add the 3. Now what do? We have to take away the 9. So remember, Lady E, when we do it, we start from the left side first. Always start from the left. I don't know if that's what's tripping you up. We have to start from the left first. That will always be first. That's what we're doing, right? So now what we're doing is we're doing the 9. So we do 9 minus the 9. When we take away the 9, what are we doing? When we take away the 9, there's not enough beads to take away the 9. Ah, Lady E, this is easy. This is easy. Why? Because there's nothing to it. Minus the 9 is equal to minus the 10 plus the 1. So we minus the 10 and then plus the 1. So we minus the 10 and we plus the 1. So my final answer is 32. Did that make sense? So when you do it, you have to make sure you go from left side first. Always go left and then right. That might be the difference. But don't forget, right, that you could do it this way. Minus the 9 is equal to plus 1 minus, I'm sorry. You can also do minus 9 is equal to plus 1 minus 10. So remember that you can do either or. It doesn't matter. It doesn't matter the equation, the formula doesn't matter which way you go first. So just as we have the 7, we could do minus the 7 is equal to plus 3 minus 10. So it doesn't matter. This is one, this is the other. It's exactly the same. Does that make sense? So then, this is exactly the same as this. So don't be scared to flip it. This one, in the formulas, don't be scared to flip it. All right. Okay, I do have to go. But thank you again for everybody joining, and I will guys see you in my next live. Wow, 21 people still here. I'm sorry, I do have to go. I do appreciate all the comments and the questions. It does make sense though, right? And it's just easy. Yeah, have a great day. Yeah, have a great day. You too, Dean. Thank you. Yeah, you too. And then Ashley, if you have any questions, let me know. We can start going through it. Like if you want to know more multiplication. Yeah, let me know. Let me know. Let me know. Yeah, thank you, Dolce. Thank you. Thank you, Dolce. I appreciate that. All right. Thank you guys, everybody, for joining, and I will see you guys all. Hey, Karen, welcome. Thank you for the heart me, Karen. Welcome back. But I do have to leave. I got to get ready for my class. I have a student, and we're working on the minus tens. And I got to work on my book. I got to work on my book. Okay. Have a good day. Bye. Hey, Christian.